Hey everyone, this is Ms. Fisher, and this is a video to help you with the code.org Unit 7 Lesson 3 Functions with Parameters and Return Practice, the Go formative. And we did the first few exercises together during class. So I'm going to go ahead and begin with Lesson 3, Bubble 4. We're going to implement the function definition for random complement. So let's go ahead and take a look at the code for random greeting. And then we're going to use that as a template to help us with random complement. So there are lists in this program. The first list is a list of strings in different. So this is saying a greeting in different languages. And it's going to print one of the random greetings, one of the random strings, and then the name, which is a parameter. And random complement has strings that are complements. And so you're going to basically program so that you select one randomly and then address the person whose name is given as a parameter. So in the instructions, it says you want the name and then comma and then the random complement. And I think the exclamation point is included in the complement. So let's go ahead and take a look at the top here. We're going to console.log and then greetings and then a random number and plus a name. All right. And so I'm going to go ahead and actually create another variable for the index just to kind of help manage the complexity here. So I'm going to select a variable and declare it as the index number. And now I'm going to go ahead and pick a random index between 0 and the name of this list is complements dot length -1. Because we start indexing at 0, the last element will be at the dot length -1, the name of the list -1. And now at this point, I'm going to go ahead and console.log, which I think is in variables category. And now I'm going to go ahead and say name, which is a parameter, plus concatenate it with comma, plus, and then the one of these random complements. And so it's going to be complements, which is the name of the list, and then index. Okay, and so that's going to help me a bit to just understand that I'm going to pick a random index in this list and make sure I spell it correctly here. There we go. So let's see if this works. We're going to run the program. And, oh, I guess it does already have commas. So we don't need this comma. That's nice. It includes it as well. So let's reset and run. And now every time you run it, you've got a really nice random complement. Okay, it's a nice program. So what you're going to do is you're going to copy and paste the definition of random complement. Now notice that random complement and random greeting do not have any returns. They just print. And that's okay. We can have functions that just print and don't have any returns. However, if we go to the next bubble 4, this these functions are going to be similar, but the difference is going to be that these functions are going to actually return a value. So if you look closely here, this is going to return, and you can see this is going to actually return a string. That's what random greeting does. So we're going to do the same thing down here. It's going to be extremely similar to what we did in the prior bubble. But in this case, we are just going to return a string. And this string will be concatenated with the name. So we don't have to include the name. And notice that there is no parameter. This one does not take an input. It does not have a parameter. And it has a return. So describe the difference. This is very important to understand. So in bubble 4, random complement, there are two differences. Does not have a parameter, but does return a value. In other words, a string. Okay. In bubble 3, random complement, which are, let's say it's the function. The random complement function does take a parameter, does have a parameter, which is name, which is a string, and does not return a value, just prints the complement to the console window. Okay, so there are different ways to handle a given task. Okay, so let's go ahead and do bubble 4, and then we'll move on. So like in the prior example, I think it's nice to create a local variable for the index because this looks a little complicated. So I'm going to go ahead and declare an index variable. And let's go ahead and assign it a random number between 0 and the length of the list minus 1. The name of the list is, in this case, complements again. Length minus 1. And then let's go ahead and define another variable. This one we're going to return. So I'm going to call this complement, random complement. I'm going to call it random comp because it can't be the same name as the function name. It's already declared with that name. And let's go ahead and use complements, square brackets, and then index. Okay, and then of course we need to return. Okay, this is going to return a value, and the value is going to be the random comp. Okay, so once we do that, oops, I think I spelled this. There we go. All right, let's go ahead and run it, and it looks like we have a random complement. These are really nice complements. Okay, let's go ahead and move on to bubble 5. And in bubble 5, what type of control structure did you use to complete the function definition for month to season? And we're going to copy and paste it down here. Okay, so for this one, we are going to write the code for this function, and we are basically going to convert the month. So if it's January, February, or March, we're going to return winter, April, May, June, spring, and so forth. Okay, so we call on name and age with the name, which is a string, the age, and then the month that they were born. And name and age is defined here. And this is interesting because in the definition of function, you actually call on another function. So this is an example of abstraction where you basically solve a small problem and use that solution to solve a bigger problem. So they've already done age to description. In this case, they use an if, else control structure. And then for month, we're going to have to do the same thing. Okay, we'll have to use an if, else control structure. So the first question asks, what type of control structure do we use for month to season? We're going to convert the month to, which is going to be a string, to another string, which will be the season. So let's go ahead and click and drag from the control category, the if, else if. It's an if else, and we can add we've got, it could be winter or spring or summer or fall. So we need basically 4 different pathways, okay? So what kind of control structure? If, else if, and then else structure, control structure. Oops. Okay. And then let's go ahead and complete it. So if the month is equal to January, February, or let's look at the instructions here, March, it's going to be considered winter, which I don't necessarily agree with that, but it makes it more simple doing it this way. Okay. So if month is a parameter, month equal January, or month equal February, or month equal March. Then what are we going to do? Let's declare a variable. We are going to declare a local variable called season, and we're going to go ahead and, if this is true, we're going to set season to winter. Okay, so let's declare it up here and assign it. Okay. So we can't go back to block mode now because once we get from block to text, we have to fill these blanks in. Now, some people might say, well, can we just do this where we just say month equal January, February, or March? And even though this is the way we speak, we can't actually write code like that because the OR is a logical operator and the operands have to be either Booleans or Boolean expressions. So this evaluates the true or false, but February is just a string. It's not a Boolean expression. It's not going to evaluate to a Boolean. So we need Boolean expressions or Boolean values. Now we're going to do the same thing here. But now we've got 3 different months. And if that is true, then we're going to do season equal spring, or get spring. So if it's going to be April, May, or June. Oh, I forgot quotes here. April, May, or June. And again, I don't really agree with this, but that's okay. Then we're going to say the season is spring. Else if, okay. And let's do one more here. Season gets. Okay, so May, June, July, August, September, and September. Okay, then season gets, I'm going to say this is summer. And the nice thing about the else, if it's anything else, we're going to go ahead and say it is the fall. We don't have to type it out, because if the first 3 Boolean expressions do not evaluate to true, we're going to go ahead and set season to fall. And it is really important that you actually return season, okay, which is going to be a string. And from the comments here, you can see that that is the case. All right, so we need to return a string. So let's go ahead and run. And it looks like it is working here. Okay, March is considered winter, July is summer, and October would be considered fall. All right, so let's copy and paste the definition. Okay, oops, not that one, the one that we just did. I'm going to include the comments because those are important. So there we go. Okay, so bubble 6, we're going to do the longest word. And it's going to be really similar to the shortest word function, which is given as an example. Okay, so let's go to bubble 6. And here, we're going to basically complete the longest word, okay, which takes a list. So now the parameter is a list, and we're going to return the longest string in our list. Okay, and we call it up here. I'm going to let you read it on your own, but for the sake of time, we're going to use the shortest word function as a template. Okay, we're going to kind of use this as a model to complete the one for longest. So it looks like you're going to declare a local variable, and we can call it the longest instead of the shortest, set it to the first item in the list, and traverse the entire list from index 0 to list.length minus 1. And we're just going to compare the length of each of the strings with the current shortest, or in our case, it's going to be the longest. And if it is shorter, or in our case longer, we're going to replace it with that current item. And then we return. So this is a really, really common pattern that you're going to see over and over again as you take more and more computer science courses. So the first thing we're going to do is declare a local variable, and let's go ahead and call this one the longest. And the name of the parameter is a list, and I'll set it to the first item in the list. Then I'm going to go to control and use iteration, and the name of the list again is list, so it's list.length, right? It's going to go all the way up to list.length minus 1. So while this is true, and let's now use an if statement. So here we are. So if list I dot length is, in this case, greater than longest, right? Dot length. Now remember that longest is a string, so you have to compare the item, right? The string, the current string within the list you're examining. You have to compare its length with the current longest length, and if it's longer, then you want to replace longest with that particular element from the list. Okay, so if it is longer, then longest, you're going to reassign it to list I. Okay, and then at this point, once you traverse the entire list, longest should have the longest string, so you're going to return it at that point. Okay, so now let's go ahead and run the program. And the shortest name is Iowa, the longest is North Carolina, the shortest is Pug, and the longest name is Caucasian Shepherd of Charka. Okay, and when it works, it's kind of, I wish they would let us know, but I know this is correct, but it would be nice if they could tell us what the expected value is, but that's okay. Okay, so now I think we need to do something, right? We need to copy and paste. So let's go back to 6, and we are going to copy and paste the function definition. So just make sure you do that here. Include the comments. They're always nice. Okay, and then the last one is bubble 7. We're going to examine and fix the bug and explain how you debugged it. And then we're going to write about the purpose of the total with tax, the parameter name and data type, and what data type is returned. All right, so in bubble 7, let me just make sure I start over. There's a bug in the program. So if you run it, and we can look at total cost, and then we have total with tax amount. We can see that with total with tax amount, when we run the program, we check off the items on the menu we want, and the total seems like it works fine. But total with tax, we get an error, okay? And it should be more than $7, because without tax, it's 7, and we need to add tax to the total. So if you take a look here, it looks like we computed it, but we didn't return any value. So you have to actually return the total. And now if we reset and run, and I add a hamburger and a veggie burger and total with tax would be $7.49. So that looks like that works. Okay. Now let's take a look at, I'm going to let you go ahead and write that. Bubble 7, what's the purpose? So the purpose, and I'm not going to write it for you. I'm going to let you write it on your own. But it looks like what the purpose does is it takes an amount, and it's going to add the tax to the amount, and which is 7% of the amount, and returns the total amount including the tax. Okay, and then it says what's the parameter variable name and the data type. Well, if we take a look, the variable name is amount, the type is a number, and then what data type is returned? Well, total is just a number plus a number times a number, so total would also be a number. Okay, so I hope this was helpful, and if you still have any questions, please let me know. All right, thanks so much for listening, and I will see you in class. Bye, everyone.